Yes, sir, we can start.
Okay. Okay, so good afternoon all. Now this is our last topic for the entire program. Means today and tomorrow we will go for this topic, which is designing a forging component with the help of CATIA. But in today's session, we will just understand what is forging and what are the design considerations for the forging component. Means while designing forging component, what are the considerations? Means how to design that forging component. Means what is exactly forging and what are the different parameters required to consider while designing a forging component. So we will understand that and just take an introduction of that component which we are going to design using CATIA. Okay, means how to design it, and we will just understand what is the product. Okay, and how to design it with the CATIA. That part we will see tomorrow. Means exact modeling of that part we will do tomorrow, and again we will create die cavities also. Okay, required for the forging. So just we will start with the forging design considerations of the. Okay, so design considerations for the forging component. Do you know forging process? Means have you seen forging process and have you experienced that forging process? Okay. Have you seen it? No, I cannot get your answers, but you might have seen that. But someone will say that I have not seen it. But though I am sure he had seen this forging process, means I am quite sure you have seen forging process, or I can say you have done that operation also. Okay, in your blacksmithy practicals in during first year, or you have seen it. Yes, I think you have seen that blacksmith, or you can call it as a lohar. Okay, so lohar, whatever the process he is doing is called as forging, right? So he is heating the metal component and applying some uh, pressure or by a force by hammer. Okay, so he is hammering the component to achieve the desired shape of the component. Right? So it's his skill actually. Means where to apply hammer is its his skill actually. Means as per the personal skill we can get different components after the forging process or blacksmith process, right? So forging, it's an engineered process again. Means here we are using engineering while manufacturing the component. So first let us understand what are the different manufacturing processes available to manufacture engineering components. Means we can manufacture our components by machining. Means where we will have stock size material block or some round bars are with us, and then we just create machining. How we apply machining processes like turning, milling, planing, shaping. Okay, and after machining we are getting our desired product. Now and then again we have casting process where we are pouring molten metal inside the die cavity or mold cavities. Okay, and after solidification we get the component. But casting requires secondary machining. Means the component coming out of casting is called as cast component, and generally it is machined after casting. Okay, means there is a secondary machining process after casting, because we are not getting good surface finish after casting. We have to do machining definitely for the castings. Similarly for forging also. Forging is a process where we are heating the component up to the recrystallization temperature and then applying some pressure or press or hammer, okay, to achieve the different shape. So we are heating these components, okay, and applying pressure. So there are dies Means we are using dies as a hammers, means we can apply some impacts or loads on the component. So here also we need to do secondary machining process. Okay. So to achieve the surface finish, to achieve the entire exact fitment of the component, we have to do machining process, right? Then there is a process called plastic molding. Generally, it is used for plastic components, where molten plastic is injected in the dies. It is called as injection molding. There are different manufacturing processes for plastic also. That is not a today's subject, but different plastic manufacturing processes are available. Just if it is possible, we go through all these plastic manufacturing process and plastic design also, because it's important topic nowadays. Means whenever you go for any interview in industry related to plastic, they will ask you different questions on plastic components. Okay, generally what we know is what is this material, we call it as a plastic, but there are different varieties of plastic. Okay, so that is different part. Again, press operation is pressing tools are there. Yes, we can manufacture sheet metal components by press work. Okay, so we press the component using punch and die, and then or it is called as forming process. So by forming also we can get different components manufactured. So these are the manufacturing processes available for the different engineering components. But today we are concentrating on forging. So as I asked you, have you seen the process? If not, then we will see forging process. We will see some videos regarding forging process. Okay. So what is our today's agenda is going through forging process. What is forging process and creating a forging component with design considerations. So first we will see design considerations and then create a component using CATIA software. Okay. So what is forging? Forging and types of forging. So forging is a process by which metal is heated and is shaped by plastic deformation by suitably applying compressive force. Here we are applying compressive force on the heated metal, heated component. Okay, and is shaped by plastic deformation. What do you mean by plastic deformation? Plastic means permanent deformation. Okay, means if you apply some force on a component and it gets deformed, so that deformation is permanent. That is called as plastic deformation. And other type of deformation is elastic deformation, where after removal of the force, that object regains its shape, its original shape. That is elastic deformation. Okay, so plastic means permanent deformation. So metal is heated up to recrystallization temperature, and then by applying some force, we are changing its shape by plastic deformation. This is technical engineering definition. But same thing is done by blacksmith, lohar. So I think you might have seen that process. Okay. So same he is heating the component and applying hammer on it, keeping the component on anvil, and by some plastic deformation, we are getting the shape change. So different agriculture instruments or tools are manufactured by Lohar. Okay, so this is forging process or definition of forging process. What are the types available for forging is closed die forging, and in closed die forging, there are two subtypes called hammer forging or and a press forging. Okay, so we'll see what is difference between hammer forging and press forging. So this is one type called as closed die forging. Other one is a open die forging. Okay, so what is open die forging? We will see. Next is cold forging, right? Then other one is rolled ring forging. So we see these processes one by one: closed die forging, open die forging, closed cold forging, then rolled ring forging. These are the different types. In closed die forging, there is a hammer forging and press forging. So this is what is closed die forging. Okay, so you can see these different steps in closed die forging, right? So these one are dies. Now, what is difference between forging and the process done by Lohar is here forging is an engineered process. Means here instead of hammers we are having some dies. Means what? Hammer doesn't have any shape. So where to apply the force, where to apply that hammer is the personal skill actually. Means It's his skill. Means what is our requirement in engineering is all the components should have same shape, right? But if you ask to Loha manufacture the same component again, it's quite difficult. Means we cannot get the same component, exactly same component after two processes. Means same person, still same person doing the manufacture, doing the process. We cannot get the same product. Okay, and if means one person cannot manufacture number of components in a day. Means again, if there is a mass production, it is difficult. So if I ask other Lohar to manufacture same component, so again it will be different. Okay, means applying the force with hammer is a personal skill. You can say again it is an artwork. Means in past years, engineering is like an artwork. Means it depends on individual's skill. Assembling two components again was an individual skill. Okay, art means he must know what should be the fitment and adjustment regarding that assembly, doing some extra processes and assembling and achieving that particular function of, from the component from the assembly. Similarly, in forging also it's a personal skill. In case of blacksmith, but here what we did is we have created dies. Okay, means we have applied some shape to the die, and we are using these dies as a hammer so that we will get similar shapes. Okay, during the processes for the different components. So in mass production, we can get similar shape if we are using hammers of different shapes. Means as per the desired shape of the workpiece, we cannot create the hammer, and it is called as die. We are using such dies or shaped dies, you can say, shaped hammers. We are having these dies. This is the workpiece. So here this hammer or a die will have similar shape like workpiece. That's why it is called as closed die forging. So here we are getting this component at the final stage. Okay. So this is called as ram. This is anvil. On these two dies are mounted. This is upper die, lower die, and here during different stages we will get final product. Okay. So dies are same as the component. I will negative shape, you can say, yeah, inverse shape. Okay, so if component is like this, so it will have some inverse cavity here in the die, and using that die we can apply some forces on the workpiece, so we get a component forged. This is called as closed die forging. This is the example. I think you might be aware with this component or you know this component. Okay, it's a connecting rod used in IC engines or compressors. Okay, so this is the initial billet. Okay, first step will be this one, and then during these stages, we can have this component. Actually, here the component is ready. Only this is the extra material. It is called as flash. Okay, coming out during the forging process, coming out during the hammering process is removed by trimming. So here we can trim the extra material and we have final forged component. Yet it is not ready for the use. As I said, this is as forged component. We need a secondary machining after that. Okay, so initially it is forged. So these are the stages in forging process, and finally we achieve this component, right? So this is the example of closed die forging. Die will have similar shape like this. Okay, upper die and lower die. Both the dies will have similar shapes to the component. Then we can see this hammer and the press machine. So it is used for closed die forging. We can use it for open die forging also. These are machines actually. For any process, we can use these machines. So this is hammer. So here there is an impact loading. Means, uh, uh, means this is coming down by some speed and applying force on this component, which is kept here. So here there is a lower die, here there is a upper die mounted on the ram. This is ram and this is the upper die. And here you cannot see it properly, but here there is an anvil on which this lower die is kept, and this process will apply some impact or load or pressure, you can say. Then this object or workpiece kept here on the lower die will get some shape as per the die. Here it is press machine means instead of some sudden impact loading, here we are applying gradual loading. Okay, so it is a hydraulic press. Gradually it will apply pressure on the workpiece. So this is about close die. And before going further, it's better if we watch that video. There we can differentiate what is hammering and what is press. Okay, so I will share that video to you. Yes, can you see the video, sir?
Yes, sir. Yes, sir.
Okay. Here you can see specifications of these press machines. So here it is a heated material, heated metal. So using that plunger, they are applying gradual force on the component, and dies are kept inside. Actually, we cannot see the die exactly. For the lubrication purpose, he is applying some material or some lubricant there. So here there is a die. Now it will get opened to remove the component. So this is the final product. It's hollow from inside. Now here there is an animation. You can see that process, what is happening inside the die. So here it is a cut section of the die, and here you can see the change in shape of the component. Means it is actually deforming now. So I will show you again. Just watch this. Change in shape, some deformation inside the die cavity. Now see here. Now plunger is now changed, having small diameter. So this is for creating a hole inside, and extra material is coming out. Means here it is increasing the height. Now I can watch the same process. A solid circular cylindrical bar fitted already. This is the first stage where it is pushing it inside the die cavity. So first stage is for changing or creating that bottom side part. And now this is the large plunger having extra diameter material. Now here it is small plunger, it will create a hole, and that extra material will be deformed along the height, along the axis. Okay, so this is close eye forging. You can see dies also. They are creating dies for the forging process. So they are using some CAM softwares. After CAD, we can use CAM to create dies, to machine the die shape. Okay. So this is a CAM process actually. They are designing using CAD and CAM. And after creating CAM toolpath or program in CAM software, it is loaded to the machine, and then die machining will be there. Here you can see one more component. See, this is hammering, and here both the dies are moving. No one is stationary. Okay. We will see one more video. Again, this one is hammering process. Here he is taking out workpiece from the furnace, heated workpiece. It is kept in a die. Say this. If you see this component properly, see the shape of outer face. Okay. So further, while considering design considerations, means design parameters, this is the important parameter for the forging process is called as draft angle. So here there is a taper. Here also you can see tapers. So all the faces are having some tapers. Okay. So this is called as a draft angle. So we will see what is draft angle and what is application, or why draft angles are provided in the component or dies. So that we will see in presentation. But just understand the feature how the draft angle is. Can you see this cylindrical part coming out here in the die? So yesterday we talked about parallelism between two guide pillars, right? So if anyone remember that part yesterday or day before yesterday, we talked about parallelism between two guide pillars, two cylindrical components in a press tools or in plastic molds. Okay, so here again we can see these guide pillars. So one more guide pillar is here on the each side. Okay, so what is use of this guide pillar is again alignment. So there can be uh, error in alignment of upper die and lower die. Okay, so the alignment should be proper for the proper manufacturing or proper forging process. Otherwise, your edges will not get matched properly. So these two guide pillars are getting inserted in the guide bushes and ensuring the alignment of this die. Okay, so here also you can see these guide pillars and they must be parallel to each other. Their axis must be parallel to each other. You can see these guide pillars. So you can see now guide pillars properly. There are two guide pillars and they must be parallel to each other for the alignment purpose. So here you can see that animation, how the component or workpiece cylindrical component is changing its shape to the flange shape. See now it is generating a flange. This is lower die and upper die. How the material is flowing inside the die cavity. Similar type of component or flange we are going to design using CATIA. Yes, in next session we will design similar component. See how the material is flowing inside the die cavity. So just remember this material flow because it is helpful for design consideration. Just how these edges are smooth. Everywhere there is a fillet. Now there is a taper. Here you can see taper. This is also tapered face. This is the extra material coming out. You can see this. This is called as flash. And we need to trim that extra material coming out of the die cavity. So these are the flow lines. Flow lines are also important. All these are open die forgings. Whatever we have seen is open die forging. Now here you can see both the processes. Just I will take it back. See here. Okay. So in next step they will transfer this part to this one. Okay. So here it is not a closed die, open die, simple flat circular surface is there. Okay. So this is called as open die forging, where die doesn't have any proper shape. So here shape is not expected. After forging, we want to just press it. This cylindrical shape will be pressed. Okay. So this is open die forging. Die will not have any particular shape. But here there is a shape. We expect some shape from the component from the workpiece. So here die will have some shape. Here it is open die, simple flat circular surface. Okay. Here it is. They are just pressing it. Now it is shifted to the next step. See. Now we are getting desired shape here. Initially it is pressed in open die and then transferred to closed die. This is open die forging and this is closed die forging. So this is about forging process. So we have visited forging industry by these two by means of these two videos, right? Now continue with our presentation. Yes. So this is hammer and this is press. In hammer we are using impact loading and in press it is a gradual loading. This is open die forging. We have seen it in video actually. So see these two dies doesn't have any particular shape and this is just pressed. Okay. This is also open die forging. some heavy shafts. For heavy shafts, if a stock size material is in a rectangular section, then it is held in some jaw and rotated, and some hammer applies force here, and it is rotated continuously. So we can change that rectangular cross section to circular cross section by using this process. This is also called as open die forging. If you go to YouTube and see some forging videos, okay, so you can see such heavy parts which are having uh, or shafts used in marine engineering, marine applications. So, or in sugar industries. Okay, so in heavy industries we need heavy shafts. Why to use forging? We will see later. What are the advantages of forging? That part we will see later. But for heavy requirements, heavy power transmission, we need this type of shafts. So here we are using open die forging, right? In Facebook also there is a Facebook page called as Mechanical Engineers. Okay, so if you like that page, so every time whatever videos they are sharing, it will be on your Facebook page. Okay, so just go to such pages on Facebook also. So you can see different techniques used in forging, casting, different videos are there. So it will be helpful for your interviews definitely. Okay. So practically you can see how they are manufacturing certain components. This is again open die forging. Now this is cold forging. So again you can see this meaning of cold. Cold means cold forging without heating. Okay. So for rivets and for hexagonal headed bolt, you just come through these type of bolts. Where is its head is hexagonal shape and this is a round bar simple. Sometimes it is threaded here. Okay. So I don't know means whether you are seeing it. There is a right now I think it is not there, but on Discovery Channel there was a program called Factory Made. I don't remember on Discovery or on National Geography, but anywhere of these two. So there is program called Factory Made. So they have shown some factory manufacturing this hexagonal headed boards. So forging process they were using to create a hexagonal headed bolt. So there, before there will be a continuous rod and it is applied to the die, and they are applying pressure here in axial direction. Okay, so due to this compressive force in this direction, this end will get inside the die and get this shape. Okay. And again, uh, actually they show very large hexagonal head bolts. So threads are also manufactured by forging process. Means they are not doing any threading operation or metal cutting operation. So just two dies are used to create threads. They are pressing the cylindrical surface using two dies to create threads also. So for threading, they were using forging. Okay, so it's a cold forging. Generally, it is used for mild steels, those soft materials. Rivets also manufactured using cold forging. Okay, just this continuous rod is pushed in the die cavity to get this shape. Okay. And after getting this shape, they will cut this rod at desired length. Okay. Roll ring forging. This is again one process used in forging industry. I have one video, but it will take some time to show you video. You can search it on YouTube also. You will get videos of roll ring forging. So here, this is the workpiece, and it is continuously rotated by mounting this on the shaft, and continuous hammering process is there. Okay. So due to this hammering, here this width will get increased and thickness will get reduced. So simultaneously diameter is also increased. Okay. So roll ring forging means applying force at the time of rotation. So they keep this component workpiece continuously rotating and apply hammering force. So to get thin ring. Okay. So this is roll reinforcing. You just go through YouTube, you will can see different videos for roll reinforcing also. So this is about different stages in forging process. So this is sheared billet, and here it is called as upset pancake. So you have seen such process now in video. First there comes sheared billet, and using open die forging they are creating upset pancake, means the simple shape they are just compressing it, and then this shape is transferred to the die, closed die, and we will get the final shape. Right? For connecting rod also we have seen initial shape. Initial shape doesn't look like connecting rod. So they are just placing at one end, and then it is transferred to the rod, dies of connecting rod. Then after two stages or three stages we will get final component, and then it is printed. Here you can see grain flow, how the material is flowing inside the cavity. When we press molten metal due to the die pressure, this material is flowing like this. So these flow lines are again important. If these flow lines are intersecting with each other at lot of locations, then its strength is very low. Means they should be parallel to each other. So they have to check, means one has to check flow lines or grain flow during the forging process. They should be smooth and parallel grain flow should be there to achieve the strength, to achieve strength in this component. Okay. So for that, what are the design considerations we will see to get the smooth grain flow inside the die cavity. You can see these some forging components. These are the forging components, or the components are manufactured using forging process. So is there any special thing you can see? Means, or can you guess, means what type of components are these? Okay. So these are connecting rods, some flanges, some eye bolts here. Okay. So if you see the common thing in all these components is all these are power transmitting components. Right? Can you guess this one? What is this? Generally, we know crankshafts, but uh, crankshaft means the picture comes in our mind is multi-cylinder crankshaft. So we have seen that type of crankshafts only. Means we are going to search for images also only. Means multi-cylinder engines. So this is single-cylinder engine crankshaft. So if you check your crankshaft in your two-wheelers, so you will find such type of crankshaft. It is a assembled type of crankshaft. Okay. So this is crankshaft. This is again manufactured by forging process. Cutting rods, crankshafts, flanges, eye bolts. Okay, some pulleys, bushings. Then these are some components, parts of couplings. You can say the universal couplings. So these are manufactured using forging process, and all are power transmitting components. Then what is the advantage of forging process? Why to use forging? We can create these components by machining also, right? We need secondary machining after forging. Then why to go for forging process? Directly we can get this shape out of a round or solid round bar, cylindrical bar. So take the bar and machine this. We can have that shape easily. These type of components. Why we are going for forging process? Okay, these are the simple components. We can manufacture these components in the machining also. For connecting rods also, we can go for milling operation, and we can manufacture such components using milling operation. Then why to go for forging? So just understand the advantages of forging process. So forging process redefines the grain structure. We have seen that grain flow. Okay, so grain structure of a component of a material is rearranged, refines. Okay, so due to application of some compressive force, all the grains get reshaped. Or their position is refined. Means we know that uh, when the atoms are in closed or density is more, you can say, means they are in very dense uh, arrangement or dense pattern is there. Definitely there will be more strength. Okay. So it refines the grain structure, improves physical properties of the metal. What are the physical properties? So say density. Density is improved due to forging. So in machining, we can see means we are removing material. Okay, while doing machining, in machining, like milling, turning, whatever. We are removing material. Means with volume, mass is also removed. Means mass is also reduced. Right? Mass and volume both will be changed. Means they are decreasing after machining. But here, if you see the forging process, we are changing volume by compressing the component, by compressing the metal. Volume get changed, volume get reduced. But as proportion to volume, we are not changing the mass. We are not removing material. We are just compressing it. Volume is changing, but mass is not changing. Some material is removed after machining, but some will come out of the die as a flash. But as compared to volume, very less mass is reduced, right? Means here density get improved. Okay, are you getting? What is density? Mass upon volume, kg per meter cube, right? So if we are changing volume, in that proportion, mass is not changing. So definitely density will get improved. Okay, just imagine that formula. Rho is equal to mass upon volume, kg upon kg meter cube, kg per meter cube, right? Forging refines defects from casting lots or continuous cast bar. So due to this reheating the component and applying some compressive force, the defects in the material will get removed automatically. Means if we are machining the component, we will not, we don't know what are the defects inside the material. Okay, we just do some machining process on surfaces. So we remove unwanted material, but if there is a defect inside the component, that cannot be corrected. If there is a crack inside, we can check the crack, but we cannot repair that. We cannot rectify that error. We cannot, what you can say this. That cannot be repaired. That cannot be corrected. So we have to reject that component and don't use for the critical parts. But during forging process, we are heating the component and applying some compressive force. So if there are some cracks or some defects inside the raw material, that will be removed automatically. Means that blowhole or some crack get hole that means it will get removed automatically. Okay? So this is again an advantage of forging process. Forging offers better response to heat treatment. There are some heat treatment processes. Okay? You might be aware with heat treatment. Okay? So anodizing or some different processes are there for heat treatment. Okay? So forged components offer better response for the heat treatment. Okay? Forgings are more reliable and less costly. So once you create a die, we can manufacture many components. So it's not lifetime again, but we can manufacture number of components using single die. Okay, but for machining, so tool wear out will be there always. Means tool will get weird after doing some machining processes. Right? That's why it is less cost. We need only machining at specific areas. Means where there is a fitment, there only we require machining. Complete machining of the component is not required in forging. Basic shape is achieved during the forging process, but complete machining is not required. We are machining only fitment features. Okay, if that shaft is to be fitted inside the hole, so that diameter is required to be turned. Right? So these are the advantages of forging. We have seen forging process and what are the advantages of forging process. Now we go for design consideration. Means if you want to design a forging component, what should be the process? Uh, we will just discuss the process of industry. Means see, there is a forging industry. Means in Pune there is very famous or number one forging company. I think you might be aware of that company called as Bharat Forge. So it's in Pune nearby Hyderabad. So what they are doing actually means They are manufacturing connecting rods, they are manufacturing camshafts, they are manufacturing crankshafts, they are manufacturing couplings. Number of components are there, and they are manufacturing all these components by forging process. So all these are all these are not their own products. Means they don't have their own product. They are doing it for some others means requirement. Means they are the suppliers. If they are supplying crankshafts to Tata Motors, they are supplying crankshafts to Mercedes. So these are their vendors. And crankshaft is not their own product. Okay, so it is not going to fit in the Bharat Forge engine. So they will get fitted in Bharat Tata Motors vehicle. Okay, so they are supplying crankshafts, then the connecting rods, all the components for different industries. So what they are doing actually, they will get the machine component, finished component. Means if there is a requirement of some flange or some coupling by the Tata Motors, designing process will be done by Tata Motors. Means design of that component. What should be the diameter? What should be the size? Means what should be the material? Everything will be designed by Tata Motors. Means they will create a finished product. Right? Finished means ready to use. But if they decided to go for forging process, now this particular component is to be manufactured by forging. We have seen the advantages of forging component. So for a particular component, suppose they decided that we will have to go for forging process for manufacturing. So they will send their finished product model or drawing. Now they are sending models. In old days, they were sending engineer machined drawing, which is drawing of machined component, not a forging component. Okay. Now they are sending machined models. This is the ready component or 3D model of ready component, and you have to manufacture it by forging and give us the forging component. We will machine it, or sometimes Bharat Forge will also machine the component. Okay. So they have also their own machining center, machined component division, MCD. I think you might have heard. So what is the role of Bharat Forge? They are just taking their machine products, complete finished products, this model of 3D model of this machine product, and by applying some considerations like they have to design a forging component out of the finished product. Okay, so the features which cannot be manufactured by forging process, they will remove these features. Suppose there is some hole. So we are not creating a hole by forging process. If there is a small hole in a component, so that cannot be manufactured. Proper chambers, fillets, grooves. So these are the features cannot be manufactured using forging. We will get a basic shape of the component, and then fitment features are set machined after forging. So first, while designing forging component, we have to remove all such features which cannot be manufactured by forging. Then for forging process, we need to apply some parameters there. So these are the parameters. We will see these parameters one by one. Which parameters to be considered while designing forging component. So they are doing this process while designing forging component. First, they have to decide how we have to decide parting line. Means how much part will fit inside the lower die and how much part will get in the upper die. And that mating surface of two dies is called as parting line. Okay. So it's not like that if a part is of 100 thickness and 50 will go inside the lower die, 50 will go in the upper die. It's not like that. Means it's not half half. Means half will go inside the lower die, half will go inside the upper die. So as per the shape of the component, we have to decide parting line, which part will go inside the lower die, which part will go inside the upper die. So that location they need to fix first, and that is called as parting line. Okay. Then by considering parting line, we need to apply draft angle. So I have shown you the draft angle while going through videos. So there is some taper applied on the faces which are perpendicular to the cutting line or parting plane or parallel to the moving direction of that die. So faces which are parallel to the motion of die are drafted. Means there we apply draft angles. There we apply tapers. Okay. So we have to apply draft angles after parting line. Then we have to apply corner and fillet radius. Okay. So you have to apply radius there for corners and fillets. Now again we will see what is difference between corner and fillet. It at first it will look same, but corners and fillets are different. Then we have to decide machining allowance, right? So as I said, forging or castings require secondary machining. Okay, so we have to identify which are the fitment features, and there we should provide some machining allowance. So we have to keep there some extra material to be removed by machining process. Okay, so by considering its original length, if original diameter, suppose the original diameter or required diameter is 50 mm, so the diameter should be 50, 53, 54, 55, depending on machining process. So that much extra material should be kept, okay, around the basic dimension, means around the required dimension. If the diameter required is 50 mm and that face is to be machined after forging, then we will need to keep their extra material. That is called as machining allowance. We will discuss that. Sometimes ribs are provided for the supporting purpose. We will talk about ridge ladder. It's very uh, complicated part. Now we'll see or we will look at different design considerations. This is the part we are going to design. It is a flange, okay, or you can say coupling, bush coupling, flange of a bush coupling, right? So here there will be hole and the shaft will be fitted inside, and here there will be different holes on PCD. So to get assembled with the other flange. So there will be two flanges, right? So this is one flange actually. Other one will be similar, just will fit on the opposite shaft, driving shaft and driven shaft. It's why we need power couplings. Couplings are fitted on the power transmitting shafts. Okay. So if you want to connect two shafts, then these type of bush couplings are used. Okay. These are connected by bushes or bolts. Okay. So here we need this for power transmission. That's why definitely they should be manufactured by forging process, because here it is a work of strength, means strength is required as a basic uh, parameter. Okay, so we are manufacturing this by forging process. So this is the parting line, means this is the location where two dies are separated. Means in the upper side of the parting line, so this part will be in the upper die. Okay, and this part will be in lower die. So in lower die, this will be the cavity only. It's not exactly half, or we cannot place parting line here at this location. Okay, it's not as per the manufacturing process. Means we will see why we cannot place parting line here at this location. So parting line is placed here. We will see what is exact location of this parting line and what are the different dimensions. So, but just now thing to remember is this part will be in the upper die and this part will be in the lower die. So workpiece is not moving. So just one die will come from upper side and just apply the force on this. So this part will get deformed in the lower die and this will be in the deformed in the upper die. Right? Then this is fillet radius. So these inner shapes are called as fillets. Okay, this one is also fillet. 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 But this one is called as corner. So we have to fix corner radius and fillet radius also. Okay. So what should be the fillet radius and corner radius? Again, there is a proper guideline to define this fillet and corner radius depending on size of the component. Then you can see this draft angles. As I told you, the surface which is parallel to the moving direction. Die will move in this direction. It is applying pressure in this direction, compressive force. Okay. So in this direction. So these are the faces which are parallel to this, and this is called as pulling direction. This is the proper technical word. Okay. So this direction is called as pulling direction. So component will be removed in this direction. Right? Again, die will get removed in this direction. So this is a pulling direction. So all these faces which are parallel to pulling direction are tapered. Okay, so these are the tapered faces. See here. But here this is removed from this side cavity. Means this part will get fitted in the lower die. Right? So here the removing action is like this. We are removing the component in this direction, but die will get removed in this direction, opposite direction. So you can see this change. Now this draft is in opposite direction. Now taper is opposite. Here the taper is in upper direction and here the taper is in lower direction. Right? But for holes or for cavities it will be exactly opposite. So here these faces are tapered in this direction. Because it is a cavity, it is a hole. Okay? So it will be exactly opposite for cavities. Right? Now this is machining allowance. See, whatever black portion you can see here is a actual component. So this is a machine component, ready component or finished component. And this is the extra material kit around the component. On all the sides, or all around this component, there is a machining allowance. Okay? So here they have machined everything, right? It's not only fitment features, but all the faces are machined. Everywhere there is a machining allowance. So sometimes what happens means if you keep this forging component as it is, these tapers also kept as it is. Means we are not machining this area. This is not a fitment area actually. Nothing will get fitted on this OD outer dimension here also, right? So actually here machining is not required, but sometimes uh, customer or some people don't want these tapers on this uh, component. So taper is a process requirement. For forging, we need taper there. So taper is must, but we can remove it by machining. So machining is applied all over the component. Now we will see how to fix this parting line. Let us understand what is parting line. It is a meeting surface of two halves of a die. These are two dies, right? This one is die. Here there is a cavity. As far as die is concerned, only die. There is no component. These dies are manufactured separately. How to design this die or how to get this die shape, we will see in tomorrow session. Means after designing this forging component, we can get the die easily. So we will get the die out of our forging component. Okay. So this is cavity. This one is cavity, and these are the two dies. And this mating surface is called as parting line. Okay. Two dies are separated at the parting line. So this is a guideline for parting line. So this is practical design or good here if you place this parting line in maximum cross section area. So general guideline is uh, parting lines are placed in maximum cross section area where there is a maximum area, maximum material is there. So here you can see there is a maximum material in this area. Okay, so here material is very low. Here there is a maximum material. Okay, so parting lines are placed in maximum material area. So thickness of maximum material is T, suppose. Then the parting line level H is definitely, it should be less than T by 2. Means location of parting line should be less than half of the maximum material thickness. Half or less than half. Right? So if this thickness is 50 mm, level of parting line should be less than 25 mm. 25 or less than 25, right? So this is the guideline for defining parting line. If you place this parting line here, grain flow will not be proper because there is sudden change in direction of the flow. So if you see this cavity here, if we place parting line here at this location, so there is immediate change in the grain flow direction. Or if this die cavity gets separated from here, so material flow is very difficult inside this. Okay, so it is placed in maximum material area. So these are the poor locations, poor designs you can say. You cannot place parking lines in this location, in these areas. You have to place it in maximum material area. Now these are the different draft angles. Okay, these are just guidelines for different materials. Different draft angles should be there. So necessary taper on sides of the forging component to allow easy removal of the dies. So what is use of draft angle is easy removal of the die. Okay, due to this taper, the die will get removed easily. Otherwise, due to friction, the component will get stuck inside the die cavity. So it will be difficult to remove this die from the component. Okay, that's why there is a taper. So when we are removing this die, there will be some gap. Okay, so it will not get attached with the component. So draft angles are used for easy removal of the component. This taper also helps uh, for the better flow of material in the deeper die cavities. If die cavities are too complex, then this taper will helps to flow the material inside these cavities. Okay, or cavities will be filled in better way if there is a taper, right? So for aluminium, the general draft angle specified is 0 to 2 degree. For copper alloys like brass, it is 0 to 3 degree. Steels, it is 5 to 7 degree. So stainless steels, again, it is 5 to 8 degrees, right? So these are the different examples. What should be the draft angle? Just wait a minute. Okay, so these are the different draft angle values. So this is guideline, but you can use different draft angle also. By experience, we may get know this values of draft angle. Again, these are some corner and fillet radii. Okay, so as I told you, for different sizes of the component, different values are recommended. Corner radius and fillet radius also. So for the upper value indicates this value in mm and this is in inches. So red color values are in inches and blue color values are in mm. So for 12.5 mm size or height of that component, if it is 12.5, generally corner radius recommended is 1.5 and fillet radius recommended is 5. For 25, 50, 100, 400. So for 400, corner radius is 22 mm and fillet radius should be 50 mm. Okay. So again, you can vary it. These are the just guidelines. But for better material flow inside the die cavity, these fillet radii are recommended. Fillet or corner radius. Right. So these are the different values for fillet radius. Now we'll see this means what we have to do in CATIA. So this is a machined component, right? Means what I said you, this will be given to forging industry by the customer. So if I want this component to be manufactured by forging process, then I will send 3D model of this component to the forging industry, right? So this is the finished product, ready to use, means how it is used in the assembly, right? This is the final product. They will not mention you dimensions of this, means what is the hole diameter. It is not required for the forging industry. Okay, what should be this chamfer, what should be the diameter of this hole and all. If there are some features below this plan, so what should be their dimensions. So that is not required for the forging industry. So what they will do is, so when they will get this component, so they will get a dump model, or you can say a non-parametric model. Okay, so non-parametric model means we cannot change these features or by double clicking. I think if you know CATIA, then you can double click on this feature and get all the details. What is the hole size? What is the date? What is the type of hole? What is the chamfer size? What is this diameter? Everything can be checked, or everything means we can reorder these features. We can resize these features, but means we can delete these features. But when we have dump model or non-parametric model, you will not get history of this component. Hence, features are not listed. Those who know CATIA or Pino or UG or any other 3D modeling software, they might have known that on the left hand side there is a history of any component. How you have created, how this 3D model is created. We get all the information, what are the different features used to create this 3D model. So we get list of this in the model tree, or in CATIA it is called the specification tree. So that tree is not available when this model is sent to you. It is sent to you in IGS format, modeled in different software. I think forging industry is using different software. So they send it in IGS format or state format or any other uh, neutral file format. It is called as neutral file format. Okay. So after receiving this machined or finished product, first we have to remove all these unwanted features. Like we cannot manufacture these holes by forging process. We cannot manufacture this chamfer by forging process. So we need to remove all this first, right? Then what is required? We will add some machining allowance on this. On this, where there is a machining, we have to add machining allowance. Then decide the parting line. So here we need a parting line, means this is the maximum material area, and we place this parting line at the half location, less than half or half location. Okay. If this thickness is 50 mm, then you can locate it at 25 from this bottom, right? So this is the parting line. Then after deciding parting line, we have to place here, or we have to apply draft angles, required tapers. Okay, we know for different materials we need different draft angles, right? So we will apply draft angle there. Then we will apply these fillets on these corners. These are the fillets actually, not corner. These are the corners, these are the fillets. So different values are mentioned in a table. I think you might have know these values. In previous slide, table was there specifying fillet and corner radii. So here you can apply fillets there on these different edges, and then this is a forging component ready for the. This is a forging shape actually, as forged component you can say. Okay, so using this forging component, they can extract dies, upper die and lower die. Okay, so actually forging industry requires dies for actual manufacturing. If they want to manufacture this component, their primary requirement is die. So how to create a die? So using these shapes and these dimensions, they have to manufacture a die first. They have to go for machining of die, and then that die can be used for forging process, right? So I want to create a die. So using this forged component, we will extract dies in tomorrow's session. Okay? So we'll extract dies and using some CAM software, they can create a tool path for the machining, and it will be supplied to the CNC, VNC machines, and die will get manufactured, right? And they will manufacture a trial component first, send it to the approval for the to the customer for the approval to the customer. Then after approval, they will start the mass production of this component. Okay, so this is forged component, and using this we can design or we can manufacture a die. So when in past years these 3D modeling softwares were not there, so what they used to do is after receiving this type of finished product, so they have to create a forging drawing for this. So using drafting softwares or using drafting tools, by considering all these parameters like draft angle, parting line, fillet, jumper radius. So they have to create their die drawing. Okay, drawing required for the dies. And using that drawing, they will manufacture dies. Manufacture first forging. Use that die for the forging, paste the component, send it for the approval. If approval is there, then go for the same die. Otherwise, if there is a problem, they have to change the die, change dimensions of the dies, and then remanufacture it. So that cycle was means number of times they need to do it. Okay, so modifications are also not that much flexible. We need to change the drawing again, send it to the machine operator. But here, if there is any error in die or the first component is not proper, is not there are some errors, there are some modifications. So we can directly modify this model of forging component. Okay, so you can change or you can modify this forging component. Then die drawing will get changed automatically. No need to draft that drawing again. Okay. So whatever drafting with you will get changed automatically, and you can send that drawing to the die department for the die manufacturing. Or uh, you can say it is not required to send a drawing actually. Means if they are not using CAM softwares, then drawing is required. But if they are using CAM softwares, that 3D model of a die can be sent to the CAM department. Okay, or die shop if they are using CAM software. So that can be that die shape can be imported in the CAM software. So it will again generate tool path, and that tool path will be sent to machine actually, VNC or CNC machine. So that machine will take care of manufacturing that component, right? So this is the actual process how the dies are designed and manufactured. So this we are going to use for die manufacturing. So in tomorrow's session, we will see how to do it with the CATIA. We will try to create a 3D model of this forging component from the machine component. So there will be machine component ready with us, and we will create a forge component. Right? So this is our end of today's session. If you have any doubts, we can discuss.
Anyone have doubts? You can ask. Okay, sir.
Okay.
Okay, thank you.
Okay. Thank you all. We will see tomorrow.